In this video, I want to give an update related to development for DEXI, and we have just recently launched this PX4 Offboard navigation course, and we're seeing a lot of questions in Discord via support related to how Offboard works, and I want to walk through simplifying this process in this video. It will be rather lengthy, but bear with me. I think we'll have a good time and learn a lot related to how Offboard works. The specific examples that I'm going to give is one, we're going to launch this Docker Compose file. There are two containers that will be brought up. One is for our software in the loop simulation with PX4. I encourage you to go through the course. You'll learn a little bit about the ARM and the AMD builds. ARM if you're on a Mac with Apple Silicon, and AMD if you're on a PC or generally a Linux machine. And then we have this Node-RED, a container that gets brought up. And so in the README, I won't get into all the specifics here, just go through these steps. If you run into any issues, you can reach out to us in Discord. In our DEXI repo, we have some examples here. I'm just going to do a Python example. We'll fly in a box mission, and then I want to go through some of the Node-RED stuff that we're doing. This is really exciting for me personally because it allows us to quickly prototype, sort of see the data structures that are coming across, and evaluate how things can function before we actually deploy them to real hardware. Let's dive in. I'm going to show you this compose file again really quickly. So we're going to have a port 6080 exposed for SITL, and then we will have 1880 exposed for Node-RED. So let me start with SITL. You'll see here port 6080, it's running. What I'll do now is actually run the Python example of the box mission. So if you follow the instructions, you'll have a DEXI workspace. I'm going to build the DEXI Pi package, DEXI interfaces, and PX4 messages. Our packages are built. Now keep in mind, depending on your system, this could take a few minutes. Looks like this took almost 2 minutes on mine. And a public service announcement I'm going to make is you might not have been through the offboard course or messed with SITL in the past. The reason we're doing this is it's incredibly important to understand how offboard works and do all of this in simulation, because in the real world, things are very different. So we want to gain an understanding of the process, what our code does, how the virtual drone or the simulated drone responds, and then we can take that over to DEXI. Okay, so that disclaimer, public service announcement is out of the way. I'm going to source my workspace. That makes sure that we have our messages and nodes accessible to us. With our packages built, I'm going to show you guys a couple of things before we launch the example. So in the DEXI Pi package inside of the DEXI project, there's a launch file. We're going to be launching the offboard SITL bridge. It starts 3 different things. The micro DDS agent, that's what allows us to communicate with both Python and Node-RED, ROS2 to PX4, the PX4 Offboard Manager, and then the ROS bridge. The ROS bridge is specific to Node-RED, which we'll interface with later on in the video. I'll go into DEXI Pi and show you the Offboard Manager. This is a node that we built to simplify things for you. You can always do raw PX4 offboard commands, but you'll see in here we can send discrete strings into the node, take off, fly forward, fly backward, fly left, pass it a distance with that string, and we'll get the magic of navigation in SITL and in the real world. So we'll launch that, and then we're going to run the example of the offboard box mission that will initialize this method box mission and go through these different steps. You can see here there's different amounts of sleep seconds in between the commands, and so this is more of a dead reckoning. We're giving the SITL drone and DEXI enough time to complete the leg or the takeoff in each leg of the box before we execute the next. Okay, with that out of the way, let's go ahead and launch. So ROS2 launch, DEXI, Pi, offboard, SITL, and ROS bridge. And then let me just demonstrate what we have here. I'll do a
Hold flight mode.
ROS2 topic list. So you'll see all the PX4 topics, then our offboard manager, which is specifically what we're going to be interfacing with. And let me just show you Q ground control. Now I prefer to manually set offboard mode. You can do this programmatically, but it's always a good step to take, doing something manual before you go into full autonomy. So I'm going to change to offboard
Offboard
mode.
flight mode.
What you'll see here, it's red. If you go through the course, you'll learn that we need to be sending the offboard heartbeat, which our example script will do, and then we'll be able to engage the different offboard commands. So I'm going to run Python 3. Let me actually clear, so get that at the top, Python 3. In DEXI Pi, we have the examples and then the offboard box mission. So here we go. See, now we're green.
Armed.
We're
Takeoff flight
arming.
mode.
Let me go to the sim.
Hold flight mode. Offboard flight mode.
Fly forward. Fly right. Looking Q ground control, I'll zoom in here. Fly back. Fly left.
Land flight mode.
Then we toggle into land flight mode. You'll notice in the ROS2
Disarmed. Hold
project,
flight mode.
you'll see the different transition states. And then finally we land. If I go back to Q ground control, you'll see we're in hold mode. Our code explicitly stops the offboard heartbeat. So now if I toggle back into offboard,
Offboard flight mode.
you'll notice that we still have this disarm state or this error state. I'll just go ahead for example's sake, launch it one more time. We're
Armed.
green, we're
Takeoff
armed,
flight mode.
we take off.
Hold flight mode. Offboard flight mode. Land flight mode.
And then we land. So that's an overview of the
Disarmed. Hold
box
flight
mission.
mode.
Let me jump over to Node-RED now and I will do another demonstration. I'm in the Node-RED editor running on port 1880. You'll recall when you power up your DEXI and connect, you get to the DEXI dashboard and launch Node-RED. We'll be running on the same port, just the IP will be different. It's 192.168.4.1, but the cool thing is all of this works in SITL as well as on DEXI. The only difference will be our configuration nodes. So before I jump into a couple of different flows, these flows will be part of the project when you run things in Docker, and they're also available to you, I believe, in DEXI OS 0.0.8 and newer. And as part of that, we've created a bunch of new nodes that will make navigation a lot easier. But let me jump over to our launch file that we ran earlier, and I mentioned ROS bridge. So this ROS bridge runs on port 9090, and it makes ROS available via WebSocket. So in our dashboard for DEXI or in Node-RED, we get the awesomeness of ROS2 interfacing with PX4 all through a web browser. Okay, so I still have my environment running. I'm going to exit out of this right terminal. That's where we were doing our Python stuff. And go back here. We'll notice that there are these different nodes. in this PX4 telemetry flow. I'm just going to go in and show you that that's the DEXI IP address, but we want to change that to our local Docker IP. That will allow us to connect to SITL. Now, this is the thing that we're working to simplify. It's actually really annoying. I don't know how to get around it at this point, but we need to get the IP of our PX4 container. So I'm going to go ahead and click on this, go to inspect, and then I'll just search for IP address. Once again, I wish there were a cleaner way. We'll figure this out, but in the meantime, in here, we're going to grab this 172.20.0.2. Yours will likely be different. I'll go back here, and for this configuration node, you'll see under this settings icon, I have a bunch of nodes across these different flows that use the DEXI IP. So I'm going to double click it. I'll put in this IP address, hit update, deploy, and now you can see we're connected. So we're connected from Node-RED to our PX4 SITL instance, and I have a few different subscriptions here. So vehicle odometry, battery status, vehicle status, sensor combined. Now, this is what I mentioned earlier that I love about Node-RED and prototyping. I can quickly look at these data structures. These are PX4 messages coming through. So let's say I want to print odometry. I'll go over here and check out the debug node. And of course, we have our odometry message with information about the drone's position, as well as a quaternion that represents its current rotation. Let me just demonstrate this real quick. So I'm going to take off. Let's just do an example. By default,
Armed. Takeoff flight mode.
Q ground control will take off to 32 feet. So keep that in mind. That's not obviously not a safe altitude for indoors. So that's taking off. Let me clear this. And let's
Hold
look at the
flight mode.
position. So now we can see a -10, and that is in meters. QGC I have configured for feet. So I'm going to turn off this debugging, clear this. Let's look at the battery status. So now it says, let's see, remaining 0.66, so 66%. Yeah, if I look at Q ground control, we see the same thing. And then you can go through here, experiment, subscribe to some other topics, see what these outputs do, and they give you a lot of interesting information. So you'll notice these other nodes here. These are my dashboard nodes. So if I were to go over here to my dashboard, launch this, we'll see under PX4 telemetry, battery remaining, our flight mode. So for example, it says 4. Let me just change that to, I guess I'm in the air, so let me go to position.
Position flight mode.
So now it's changed from flight mode 4 to 2. So really cool. One thing I'll leave you with before we go to an offboard example is you'll notice here that I'm rate limiting these messages, 1 message per second. Some of these, I can't remember the actual frequency, maybe vehicle status and sensor combined. Actually, sensor combined, I know, runs at a very high frequency. So I believe almost 100 hertz, 100 times a second. So you can see here I'm rate limiting this to 1 message per second and then dropping the intermediate messages. So that enables just a slow, nice, clean output. Obviously, if you want to get more messages at a faster rate, you can disable this, but always keep in system load in mind and performance. I'll go ahead and disable this flow, deploy. I just like to make sure that I don't have a bunch of flows, different programs running at the same time. And we'll go over to, let me just actually show you this PX4 arm takeoff and land. So you'll see here we have some of our different nodes, our arm, our land, and takeoff looks a little bit different than this one. And so one thing that you can experiment with as you get further into development and understanding what's going on is actually look at the raw structures of these different types of messages, these PX4 messages. But in our case, the DEXI Offboard Manager node, but in our case, this DEXI Offboard Manager flow, which you see the takeoff node here, the takeoff node here, we have that all bundled into the actual node. So you don't have to worry about the message format. You can just specify an altitude and it will take care of the rest. But I want to show you this flow because it uses the exact same node that we demonstrated in the Python example. So this, our DEXI Offboard Manager. I'm going to go ahead and enable this flow, deploy. You can see here it shows connected. Let's do some experimentation with this Offboard Manager flow. So we'll see these inject nodes. If you're not familiar with Node-RED, it's, in my opinion, very intuitive. We have a full course related to DEXI sensor wiring and programming, where we go through several different flows and introduce you to these nodes. But these are inject nodes here that allow me to just click and inject a message into the node all the way to the Offboard Manager. So I'm going to inject this timestamp into the ARM node. So let's do this.
Armed.
You'll see here in Q ground control we're armed. Let's see if we can run over to Gazebo. See the propeller spinning.
Disarmed.
You'll know that PX4 will time out and disarm if you do not give any input. So let's go ahead and move forward with an arm and then a takeoff. We'll take off to 2 meters. Arm.
Armed.
Takeoff.
Takeoff flag mode.
So we switch to takeoff. We're gaining altitude. You can see us
Hold flag mode.
here going above the ground. Okay, so as we learned previously, and I like the fact that PX4 makes offboard a bit of work to achieve. Obviously, we don't want to make it too easy and accidentally send bad set points to the drone and have it fly away. So that's why we need to start the offboard to engage, or the heartbeat to engage offboard mode. So I'm going to show you that I'll try to set offboard mode. I'm in the air. It's not allowing me to do that because there's no signal. So I'm going to start it now. Then let's go to offboard.
Offboard flag mode.
You can see now we're in offboard because we're sending the heartbeat, and now PX4 is waiting for us to send some set points. So let's do a forward 1 meter. See, we're moving forward. I have to zoom in a lot. Backward. Right. You notice that the drone does appear to be moving fairly quickly. You can always adjust a parameter here. Let's go into vehicle parameters. That param that we want to adjust, this applies to DEXI as well. So I'm going to change this to 1 mile an hour for this MPC XY velocity max. All right, let's now take a look. Once again, I know I sometimes reiterate safety, but do not make these changes on your real drone while it's in the air. I just did that in SITL, but that's okay. So I'm going to go left now. You'll notice we're moving a lot slower, something more manageable. Obviously, if you're doing any sort of precision flight, you want to slow this down so that you don't have too much overshoot. So let's just yaw right and yaw left. And then obviously you can string these nodes together like we did in the Python box mission example. You could have a sequence of nodes, add a delay, and then string together your navigation logic. So let's just go up real quick. Go up 1 meter, up again. See, we're moving around. And Gazebo here. So let's do another example where I'll move backward, I don't know, let's say 10 meters. Done. I have to redeploy that. So I'm going to click backward now. See, it's coming back. go to Q round control, moving back 10 meters. So I know I've covered a bunch in this video. I'll just leave you with the fact that if you have any issues, please jump into our Discord. There'll be a link to it beneath the video. I will put a link to our offboard navigation course. I really just wanted to give an update of some of the stuff we've been working on related to offboard mode with PX4 using both Python and Node-RED. We appreciate you following along, and until next time, thanks for watching.